Welcome everyone. In this video, we're going to look at a question involving the ideal gas equation, PV is equal to nRT. It's an A-level chemistry past paper question. Details are in the description. Let's get started. This is the information given at the beginning of the question. The diagram represents two glass flasks, P and Q, connected via a tap. Flask Q has a volume of 1.00 times 10 to the 3 centimeters cubed, is filled with ammonia, NH3, at 102 kilopascals and 300 Kelvin. The tap is closed and there is a vacuum in flask P. The gas constant R is equal to 8.31 joules per Kelvin per mole. Here's the first part of the question. Calculate the mass of ammonia in flask Q. Give your answer to the appropriate number of significant figures. I've also abbreviated the information given earlier, leaving just the essential details. You have to know the correct units to use when tackling ideal gas equation questions. You also have to be able to convert between these units. This is a useful skill for many other chemistry calculations and is also relevant to other scientific subjects. The ideal gas equation can be expressed as PV is equal to nRT. P is the pressure in pascals, V volume in meters cubed, N amount of substance in moles, and T temperature in Kelvin. We must convert to SI units. This ensures that we are consistent with the ideal gas constant given in joules per Kelvin per mole. To convert the pressure given in kilopascals to pascals, multiply by 1000. To convert the volume given in centimeters cubed to meters cubed, divide by 1 million. If you are using standard form, this can be expressed as times 10 to the minus 6. We are given the temperature in Kelvin, so we don't need to convert this. If you are given a temperature in degrees Celsius, convert to Kelvin by adding 273. Each of the variables from the question is shown here converted to the correct units. Next, we have to rearrange the ideal gas equation to make amount of gas, N, the subject. N is equal to PV divided by RT. The amount of gas works out to be 0.040915 moles. Next, we have to use the expression amount of substance is equal to mass divided by molar mass. Rearrange to make mass the subject. I use the letter G to represent mass. This is a reminder that mass must be expressed in grams. Mass is equal to amount multiplied by molar mass. The molar mass of ammonia is 17.0 grams per mole. The mass of ammonia works out to be 0.696 grams. The data in the question is given to 3 significant figures, so the final answer must also be given to 3 significant figures. Here's the next part of the question. When the tap is opened, ammonia passes into flask P. The temperature decreases by 5 degrees Celsius. The final pressure in both flasks is 75.0 kilopascals. Calculate the volume in centimeters cubed of flask P. Once again, we can use the ideal gas equation. This time, rearrange to make volume the subject. When the tap is open, V is the volume of both flasks. A temperature decrease of 5 degrees Celsius is equivalent to a decrease of 5 Kelvin. The pressure, P, is now 75,000 pascals. The amount of ammonia gas remains unchanged. Using these values, the combined volume of both flasks works out to be 1.3373 times 10 to the minus 3 meters cubed. To find the volume of P alone, subtract the volume of Q from the combined volume. Finally, to convert from meters cubed to centimeters cubed, multiply by 1 times 10 to the 6, or 1 million. The final answer works out to be 337 centimeters cubed. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.